This is the video about reference variable in the Java. In Java, there is like a file reference data types. This is definitely a file. This is method code, including class string interface array in enum. First, we come up with the class. Class is the user-defined data type in the Java. And for example, when we in here I create the class employee, including the field integer, this holds the employee ID, and the guest and set the method. So you see here, this is the easy example of class. Here in the main, I create the employee object. To create the object, create class objects in Java, we need to include the keyword new in front of the object. So here, what it's really do is that, like, I create the employee. It's going to create the name, allocate the name into the stack. And then for the new employee, for this object, it's going to allocate all the information, including the field, into the heap memory. And this one is reference into the heap memory. And what is the in Java, the variable is passed by value into the functional. Here is metadata. We pass the actual object into the function, so that's when so that's reference type allow us to modify the original value. What this really means is that I want to take an example inside my environment. First, I include the integer s in is equal 5, and then I call the method like increment by 1. Okay, this is my user-defined function, but I just type it here right now. Okay, create that method here, create the method. And then you see here that I'm gonna try to run this program. I pass the test the value of 5 into the function, so that it's gonna increment by 1, right? Now I'm not return the first of all, I test E is 1, test E is incremented by 1, and then I increment and return test E. What I expect it does, that is for incremented by 1, so the result gonna be increased to 6, right? And I hope that test type E is gonna increment by 1 also. Let's see. Right, the test the variable in here still be fine because the variable is belong to when I pass into it, it's create a copy of the test, so it's make a copy of 5, so that when I increment, what it really do is that for example the stack right here, right? I first create the element, the test E, which equal 5, right? And then let's call the method. Let's call the experiment by 1. So call the method. It's make the copy of test, which also equal 5. First inside the method and experiment by 1. So it's increment by 6, right? And then this object belongs to the method scope. So when it's after scope, the field and all things inside the method is going to be deleted automatically, deleted by Java JVM system. So that when I return, it's going to remove everything. So that's one junction. So that using the reference type allows to modify original value. What is really mean that because we pass the reference, so this means that we pass the address of the variable. This is the concept in the Java. When we pass the pointer into the function, it makes a copy of the address. So all the copy and the original also pointing into the same heap. So that's whenever we change the data inside the heap, it's not inside the heap. So that's in the function. If we change in the data, it's gonna change into the original address itself. And another thing, reference type is a string. And there is some key spoiled by string in Java. Strings are immutable. It means that when we create this, the value cannot change. The only way to change the string is that we create another string so that we assert back to the original one. So when it's created, we cannot change it anytime more. And the string store the string literal are stored in the string constant pool SCP inside the heap. As you see here, inside the heap, I have the strings pool in here. All my string is stored in here. Which is why we hold refer to string. Okay, this means that this is this is the sample of the string. I create the string s1. It is the hello, so that it's gonna go into the heap, right? And create the hello variable inside the string pool, and then I create the string to hello. The mechanism of the strings in the Java is that is the first one to come up to the string pool, and then it's gonna check whether this string already exists or not. If it's not exist, it's gonna create one for itself. But for this case, right, you see here for string s1, I always create the string literal hello. So for string 2, it's gonna come up to string pool and it check that it already has the hello right here. So it just points into the same string literal is pointing to the same address. It's not create another one. But if what happens if we create the new string hello, right? What it's really do is that it's first create the string to name is stack, and then it's gonna point into the heap. But rather going to string pool, it's gonna create the new string itself. So it's going to create the string itself, as you see here. And when we want to compare these two strings are equal or not, there's going to be some error happen. For example, here let's create the string similar to sample, right? String str1 is equal hello and string 2. Okay. When I compare it's going to be true because it's referring to when we compare. And think a little bit about when we compare the string is that it's going to compare the address of the string. So strings 1 and string 2 is pointing into the same memory address, so that it must be the true, right? It's true. But what happens if I compare this into the string 3? It's going to be false, because as you see here, I create another address for the string 2, so that it not be the same. But as you see here, from the it's the hello is the same, right? So how can I can compare them? I use another way. I use the strings static BOS method. Is the method like is equal. I typed the wrong system. You can see here, right, it is true because it's going to compare each register to each other, but the task compare the address, so that it must be returned true. Okay. And another reference type is the interface, and there is some key feature of the interface. Interface define a construct. It means they only display the matrix but do not implement them. And as you see here, I forgot to create the implemented interface for the portion. Class implemented interface must provide an implementation for all interface methods, which means that the class implemented portion interface is must provide because, for example, as create the class right here, as create the source right here. The interface of the person, right? As create the public string profession is the method of the interface. So for the teacher class, when implement the person interface, it forces to provide implementation for this function. So here I just return some basic strings like strings and software engineers for the engineer class. Implementation and owners of in-class can be referenced using the interface type. What this means is that, for example, in the main, I create the person type of software engineer and I reference into the engineer. Right, it is valid, and the teacher is referenced to the teacher with the type person it is valid, and the teacher is holding the teacher invalid, but the engineer and the software engineer is still valid, right? What is really is that the Java allows like another feature of the phrase that we cannot create the instance of the person interface. What it really means here? For example, like when here you see we create the person object, but it's not allowed because it don't have the implementation. So what we can use to hold the reference for each try class. For example, for the software engineer, right? This is the person type, right? And it's going to point to the heap. And here it's going to hold the engineering class. On a whole instant reference of the try class is allowed. For example, like when we want to create an array, for example, and the advantage of this is that when we create an array, which hold all the try class of the person, right? What we want is that it's going to hold like the person. So that we can and then we want to print all the professional methods of this array. It allows us to do so, but for example, if we just want to, if I just put this as engineer, it's limited to engineering only, so that we can not put the teacher into this array. But if we use the person interface, we can put both of the engineer and the teacher, so that we can have more control. And the first type is an array, and the feature of the array is that it's the each sequence of memory storing the same data type. The same data type, and you see what is the same data type, right? The engineer and the teacher is still the same person data type, right? So it allows to create an array of the person that hold the teacher and engineer object. And here I create the run with the new keyboard is now that we allocate it into the heap. There's nothing special about itself, so I'm going to move on to wrapper class in Java. Why we need a wrapper class, and what we first I want to talk about what is the wrapper class in Java. Wrapper class is like a class that holds the primitive data type. For example, I have a class integer. The size is whole an int. It's all the methods, and that is wrapper class provide us a lot of methods, provide this stylish methods so that we can use it. As all a primitive have its own wrapper class, and that's why we use the wrapper class, because like I said earlier, that because this data type is stored into stack, so whenever we call inside the methods, it's gonna be removed and we cannot modify the original one. So if we use the wrapper class, so that it's gonna point it into the same memory, for example, right? So the as methods in earlier I mentioned as by 1. If I pass the integers, wrapper class is gonna pass the address of this because it is the reference type. So we have this inside the heap, right? So when we pass into the function, it makes a copy of the address. So when we increment by 1, it's gonna update the memory inside the heap. So it allows us to modify it. And another reason is that in the collection in Java only allows wrapper class rather than the primary type. So if we want to use the collections, we have to use wrapper class. And another concept is auto function and functions. Like this is the way that we transform the primary type to the wrapper type. And here Java automatically converts primary type into wrapper class. When it is player, I discard the int primary type num in 10, and then I assert into the wrapper class, so that it automatically does for me. Here I functions, it means that I convert the wrapper object back into primitive type. Right? It's the first type, and the Java automatically do it for us. And another concept is constant variable. A constant variable is something that whole value cannot change when inside. So to achieve this, we just push the keywords in final, right, inside the before the time of the variable, so that it cannot change. And another is static final variable. Why we need to have the static? It's the class level constant, right? For example, for the class example, we push the static final, which means that this variable gonna belong to the class itself, not the object. So every object going this from this class will hold the same address, and we don't upgrade this variable, and we don't want this variable to be changes. So we use the static final keyword. That stands for constant. Another concept is while heap. That's why we use the heap first as stack in Java. First, we want to see about the heap spread. This allocates memory dynamically store objects according to executions. What it really means is that, like when we create an array, and we need the one is have a fixed size, we want to increase the element inside the array, we can allocate the element inside the heap, so that we can achieve this at the runtime. And storage, right? I show you this here. This is the application for the collection and array. when we want to assert or delete element dynamically. Otherwise, objects remain until they are no longer referenced. Right, in C++, when we have to control the object, the reference type by ourselves by freeze the memory into the heap. But in Java, we don't have to worry about it because JVM in Java automatically builds the garbage collector that will remove the unused reference variable. Several address in application, so this when we application for presentation is here easy for is reference. As minus execution storing local variable must and return address. As you see here, it holds the name of the variable and then it's going to reference inside into the object in the heap. And the capacitor of the heap here equals down the capacity of the stack memory. This whole thing. As you see here, it just holds the property of the type and the reference to object, not the object itself, because the object is allocated in the heap and the name of the storage inside the stack. And why we use heap memory in programming? First is dynamic memory allocation, right at that side, that we can when we don't know what is the memory size, and it's a real scenario in the life, right? But we want to increase the element inside the array or any collections. We can use the heap because it allows us to define in the running time, read time, in the combine time, regardless to the stack. Launch memory available. The heap is larger than stack. Persistent beyond the function scope, which means that when we use function scope, it allows us to modify the element because we make a copy of the address so that it's pointing to use the same address in the heap. So that's when we get the value inside of the address. It's transferred to the original one. And it supports for the component data structure, the collection in Java, manual memory management. And last, memory. Heap memories can be allocated and deallocated at any time. Quick control by the JVM, I mentioned earlier. Okay, when we do store array objects, we use the heap. For the execution, you see the structure. There is only the apprentice order. Heap is that is slower than stack. And another is manual memory management includes the risk of memory leak. And this kind of problem that occurs in C and C++, but in the Java, we have a JVM that can the garbage collections for us.